2024. We are here to present our capstone project, which is the IproTech microcontroller, a microcontroller-based location tracking with temperature alarm and monitoring user interface for a construction worker. So I am here with my co-speaker, Ms. Rain Esguerra, and I am Jan Michael Gamboa. So our study focuses on improving construction workers' safety through a smart hard hat integrated with real-time monitoring and alert features. Okay, let's go move to the introductions. Okay, so here we go. So our introductory introduction. Okay, so the purpose of our project is this. The construction has high accident rates, especially in the Philippines, and we have common hazards like uh, falls, heat, and delayed emergency responses. Also, IoT improves real-time monitoring and safety. IproTech Hard Hat offers location tracking, temperature monitoring, and instant alerts to help prevent accidents. So by the next step will be the background of the study.
The background of the study. Construction is a vital but highly dangerous, with risks like falls, heat stress, and equipment accidents. Existing safety methods are not enough for fast peace site. IoT technology can be improved real-time monitoring, alerts, and emergency responses. This study aims to develop an IoT-based safely system to protect workers and meet global standards.
Hey, thanks, G. So let's go move to the scope and limitations of the project. Okay, so here we go. The scope. All right, so we develop and test the iProtect Smart Hard Hat for construction safety. The features, GPS tracking, temperature monitoring, fall detection, and the mobile alerts are also been tested. And we focus on real-time hazard detection and emergency response. This could include topics that we have just on some sites, and then battery life and sensor reliability affected by conditions. Sometimes heat could. False alarms are possible from construction vibrations. So the way that the hat usually take in vibrations is through sensing if the x and y axis are in a different in unusual place. So what this means is usually if the hat is placed horizontally and it detected vibration, usually those can cause false alarms. But the good thing is that it does contain a vibration sensor to some extent. So and then we have limiting testing scope, so it would be a lot better if we're able to do it on a larger trial. Okay, so let's move on to the next. All right, okay, right here, review of related literature.
Construction is high risk. Traditional hard hats have limited protection. IoT smart helmets track location, temperature, and falls and faster response. Philippines construction needs real-time monitoring to reduce accidents and heat risk. These are our reference that are relevant to this recording.
Okay, so for the next slide would be the methodology. So in the methodology section, we use the modified waterfall model. So the process started with requirement gathering and analysis, followed by design, development, testing, implementation, and maintenance. So the reason we chose this is that it is easy to go back from time to time through different flows. What it means is that if ever we want to go back to a specific place, whenever we're trying to design the product, we can always go back. So an example would be if we had a problem during the testing, we could go back and do we have taken the usual waterfall design where it only goes straight. So with this model, we're able to go back and easily plan for contingencies, right? So let's take a look at the next one, which is the test results. So this is the test results for the
So this our test result overall
in the
well overall evaluation result alpha test and IproTech. These slides show the comparison between alpha testing and combined beta results from laborers and engineers. The alpha test overall means that 4.2 while the combined beta test is 4.8 and both are interpreted as excellent. Next. This hour, the second copy of technical observation. RFID is maintaining current reader configuration and polling interval. Firebase sync keep the current data model, contain real-time updates and indexing. Vibration sensor raise threshold to minimize false positive. Temperature sensor retains sampling rate and filtering logic. Physical assembly, larger shell options, TD wiring, add sturdy strap, snacks.
So for our conclusions, okay, so based on our findings, we conclude that all key functions of the system are working properly. This includes the RFID time in and time out, and then we have the SOS signals, the fall and heat alerts, GPS tracking, and the web dashboard. In terms of performance, alerts are fast, and dashboards updates are responsive. The system also works well with site networks and can provide multiple hard hats. It is reliable because it can recover after Wi-Fi or power interruptions. And overall, the combination of ESP32, Firebase, and React or Next.js resulted in a clean, maintainable system that is ready for field use with only minor refinements. So we can move on to the last page, which is recommendations. So, oh, it's not the last page. Okay. All right. So the recommendations would be definitely these would have been definitely would be better if they are incorporated in the system. So one of these are the sensors. So we tighten the threshold, add hysteresis, debounces, idempotent events, and to verify the GPS. So everything to be even more accurate since it is a real time project. And the power, definitely a bigger battery or smarter duty cycle. Show battery percentage plus the low battery alert since that still lacks on the current prototypes that we had. Hit UX, so clear heat badges, trends, so auto escalate supervisors. So there still needs to have the system itself needs to have someone to look after the website itself since it the main purpose of it as of the moment is for it to send information to superiors or even safety officers on site. And then for the hardware, oh wait, we are at the data. Okay, the data. So detailed logs, CSV, JSON exports, simple incident analytics. So I think this would be a very good scalable feature in the future if ever project continues. And then what else is scale? So optimize Firebase, load test, plan sharding. So that will be definitely in mind as well in the future. So hardware. So definitely lighter shell since the hat itself almost weighs a kilogram, but definitely still strong. But stronger straps definitely as well. Tidy cabling and IP rated enclosure. So and then resilience. So offline queue, safe replay on reconnect. So definitely one of the stuff that we need, especially on uh, construction sites. And then ops, so OTA firmware, versioning, rollbacks, calibration documents, documentation, and then fixed start guide. Definitely one of the things that we also have to look out for since definitely if it's going to be used on site, nobody knows how to operate one of this. And then integration, so SMS, WhatsApp, email alerts, geofencing, indoor beacons definitely would be one of the best ones that we could have. Since Sims also are able to help with the GPS calibrations. I think one of the best things that we could do is integrate SMS and even use like SIM cards on it as well. And then privacy, yeah, definitely role-based access with minimal retention. So user are able to view their logs. So also would be a good importance when it comes to their daily time. Okay, so for the next slide would be the diagrams.
For a system architecture, this helped out to how we construct, how we build the hard hat. This will be about the diagrams that has served an important role in our capstone project. This slide presents it, the system architecture. IproTech at the center is the ESP32. This is our main source, which acts the main controller is connected to multiple components such as a RFID reader, GPS module, temperature sensor, ultrasonic sensor, motions and vibration sensor, OLED display, buzzer, relay, and exhaust fan. Next, this our the entity relationship diagram ERD. This slide show the entity relationship diagram of ERD system. This allows us to better organize the database of HyperTech. This show how it works and how we do that. Next.
Okay. So for the storyboard. Okay. So for the storyboard, here is how you're able to use the hat itself. So from top to bottom, so left to right. So you're going to be able to follow. So all right. So worker will be provided their own worker ID. Okay. So the worker IDs are RFIDs card that will contain your ID, what do you call it? Your your information, your workers' information. Is we also have another one of these, which is the Wi-Fi and the database RFID tags. So that's one of the stuff that we have. So here, on the first uh, photo that we have here, the worker is able to tap their card on their hat. Therefore, they are able to enter their credentials. Then the second thing that they can do is that they will be provided with a Wi-Fi card or an RFID, RFID card that contains a two things. Okay, the two string, which is the password for the Wi-Fi and the API key for the Firebase. So whenever they tap that is, the hat itself will automatically place those within a variable that then could be called by the on the initialization phase, and then therefore they can communicate through the online application, the web app. Then the emergency calls that we have um, if somebody that's using the application, they actually have an ability to call a specific uh, group or a specific person. It depends on what position do they have. If they have a position higher than a foreman, definitely they're able to call the entire fleet of construction workers. But if they are limited to a foreman or someone who oversees the certain group, they're only limited to their group. So they also have which is that's the call summon one right below the emergency call. So that's when you are able to call someone specifically, right? And then so with the high heat, this is a actually we have a system that whenever it detects a 40 degrees Celsius threshold, it automatically updates the all the nearby hard hats or just one of them receives a 40 degrees. The highest threshold will automatically set on the web app, and then the uh, all the hats in the vicinity with this same heat threshold of 40 degrees Celsius will start beep same time. So okay, which one is this? Active time masking. Okay. So if ever the ship is finished, so the worker can hold the button, provided buttons on the right side of the hat, which then will activate the timeout mode. So that's where the function for time in and timeout would come along. So after doing that, they just have to scan their ID again. Then it will automatically log it to the system, the time that they spent. with the time that the time in and the time out. And then for 5 seconds, so okay, so if the button was held 5 seconds during the startup, this will delete the worker information. Okay, so regarding this one, so this is for redundancy. The main reason that this is here, because if ever the hat suddenly disconnects, it needs to have a way to be able to reconnect to the Wi-Fi, be able to reconnect to the what do you call one of those stuff, um, to be able to use the same worker ID as it was before. So you don't need to put the card again to just to log in again. So if you want to delete the worker profile and then just hold it for 5 seconds, and then it's gonna ask you on the little OLED screen right in front, and then you can just confirm it there. It will delete the information in there. And then you can tap another card. So it is reusable for other workers. So it's not one-to-one situation. So during the startup, press the button to delete the Wi-Fi and database information. Okay, so if ever the hat suddenly died and then it restarts, right? Um, it will prompt up a little string that will ask if you would like to delete the information that is included in there. So the reason for that is that sometimes when we turn off the hat and when we turn it back on, there is someone already registered on the hat. So the reason for that is that if you turn off the hat and you turn it on again, and then if you wanted to delete it so that somebody could use the hat, definitely one of the things that you can do. And as well as if you wanted to change the database information and the Wi-Fi information as well. So when held for 10 seconds, this will activate the emergency signal. So it will immediately alert all the hats on the vicinity. So this is definitely for emergency cases only. So hold the button on the hat for 10 seconds. It will activate the SOS signal. This will also alert uh, the one who's responsible for the web application. So this will be visible by everyone, and everyone in the vicinity would also have their hats beeping on a different noise compared to the SOS signal. So let's check in the next one. So for the flowchart,
So this our flow chart present the logic of how the system works. It start by checking whether a user is already registered in hardhat. If not, the system scan the worker RFID and the Wi-Fi RFID tag, then the contains normal operation. During the operation, the system can respond to events such as emergency calls, high heat, summon alerts, and group SOS. It also shows how pressing and holding the buttons triggers specific function like timeout or SOS. Overall, this flow chart summarizes the decision making process of the system.
okay, perfect. Thank you very much. So okay, so for the block diagram, so this is the diagram. So that will show what are the included modules that we use and how they interact with each other. So all right, so let me go ahead and just check this out real quick. Okay, so this is the block diagram. Okay, so as we can see that we do have a lot of Python stuff in here. So lots of sensors. So this includes the GPS modules. This says that it's a GPS module, but this is actually a DHT. Okay, so this will detect a changes in the environment. So that includes temperature and humidity. Okay, and an accelerometer. So this is the one responsible for um, the X and Y axis. Uh, that will detect if the hat is actually upside down or like flipped down. And that works in unison with the vibration sensor. So the vibration sensor sets a threshold for the accelerometer to make sure that it is detecting vibration and it is on an angle that is supposed to be not to be on that angle, since you want the hat to be not perfectly vertical but somewhat vertical so that it wouldn't trigger. Um, Okay, so they do work hand in hand just to make sure that there are no false alarm. But one of the good things about it is we have an ultrasonic sensor. So the ultrasonic sensor act as a confirmation for the hat. So this will detect if the hat is actually turned on. So I mean, not turned on, but if it's actually worn by some. So you might ask that why you didn't use an IR sensor instead. The main reason for that is the IR sensors don't work against anything that is a darker color, especially like the hair. So it wouldn't detect anything. So it's not very usable when it comes to the Sam's project. So the RFID scanner, definitely one of the most important parts, since this handles the time in, time out. It also handles the database and the Wi-Fi information. So we have two kinds of batteries. So definitely we could work on this as well in the future. 9-volt batteries to work with some other modules like the fan that is rated for 5 volts and a lithium ion battery that is rated for 3.3 volts. So this powers the lithium ion battery powers the entire thing. So it is capable of powering the entire thing, but with the 9-volt battery solely for the relay. It handles the relay part with the exhaust fan. So so that is able to at least eliminate the fact that we need to have a step up module, so which would definitely increase the size of um, the hat. So we went through this approach. So for the other modules, the input output modules that we have. So we have a button for the confirmations and all those SOS stuff that was mentioned earlier, and a buzzer for the each beep codes that was in that will be in the documentation for the instruction manuals. And we have the OLED modules. This is the one that shows the current temperatures, if your GPS is on, if you're receiving what do you call this thing? If there's an emergency, anything source of that stuff, you will see it here. If a confirmation to remove specific data, yeah, definitely it will appear in here. And then RGB module to just show if something is urgent, this lights up with a different colors, depends on different situation. If it's heat signals, it blinks red. And then if it is an SOS signal, it blinks on a certain pattern. And then we use a Firebase, real-time database, and we also have a web app to come along with the entire thing. So for the final part, which is the closing line, let's go ahead and take a look at this. So that concludes our presentation. We really appreciate that you listen on what we have to propose. So we are the group 24. We present to you the IproTech system, and we really appreciate you listening to the presentation. Thank you very much.